Happy Friday, everybody. How's it going?
It's going well. We're almost to the weekend.
Yeah, well, and for some people, it probably is the weekend. So,
Yes.
yeah, welcome. Cool. On today's TGIF show, we got Ben Wilson and Michael Burke. For people who don't know who you are, do you want to give a quick intro?
Yeah, hey, I'm Ben Wilson. Been in the data science ML space for I don't know too long. Before it was something that was cool. Worked for a couple of companies in roles like that, and I've been working for Databricks for the last almost 4 years now.
Wow.
Was doing field work for the first 3.5 years of that, and then the last couple of months I'm working in on the team that supports ML Flow.
Hmm. That's really cool. I'll have to get into that. That's really cool. How about you, Michael?
Yeah, I'm Michael Burke. I'm sort of the opposite end of the spectrum. I've been working in data science for about 3 years now. Started in an algorithmic hedge fund, and now I work at a company called Tubi, video streaming, so movies and series that are ad supported. And I mainly focus on experimentation, but do some ML, do some general data science, decision science, and yeah, that's me in 2 seconds.
Cool. Thanks. Yeah, and it was actually you guys I met Ben at the what was it, the Apply comp about last month for Tectons. So that was cool. I followed his talk. His talk was way cooler than mine. But and I was like, oh, this guy's pretty cool. Then I met you, Michael, on a podcast that we were on. What podcast do you guys host?
It's Adventures in Machine Learning. It's a podcast on the top end devs uh, podcast circuit, I guess.
Circuit. Cool. Yeah, it's a fun podcast. So for the audience, definitely go check out their podcast. It's really good. They got a lot of good guests on there. Not me, but the other ones. So, so it's cool.
No, your episode is great. I don't even know if I think yours just got posted last week.
Okay,
But
cool.
it was
Yeah, I
good.
just got a notification on Spotify. It's like, hey, this episode's up. You should go check it out. I'm like,
Nice.
I will do that. That sounds like a lot of fun. So cool. Well, I think the topics today we want to talk about was a couple things like building ML pipelines from scratch. We can get into that. ML engineering, data science, kind of the whole nine yards. So um, I guess building ML pipelines from scratch in 2022, what does that look like?
It's if we're talking about tooling, there's a lot of stuff out there. But what we were talking about earlier this morning on our podcast was something very similar to this around more the process of it and where do you get started when you're talking about tackling a new project. And one thing that we didn't mention, Michael, in our talk earlier was about knowing where your data comes from. I think that we touched on it a little bit, but I came up with an analogy after we had stopped recording where I was thinking about um, using data for a new project is kind of like buying a used car. If you know something about cars and you go into a dealership, you can with confidence drive the thing around for a half mile and be like, yeah, solid car. Seems like it's working well. But if you don't know anything, you don't have any context about cars, you're going to get told everything's good to go, solid. And you could have just bought the biggest piece of garbage ever. And within a month, one of the wheels is falling off. Same thing with data coming into an ML pipeline project is you really got to take it to a mechanic, and a mechanic for our world is not just talk to the data engineers, but talk to the people that give the data to the data engineers, which are usually developers, and say like, hey, how do you make this data? Like, where does it come from? How often does it change? What controls do you have to make sure this is correct? Because if you're not doing that or understanding what that data is, you could have just bought a lemon of a project.
It's funny too, because if you walk around in any company and just like find out all the people who touch the data, analysts, business stakeholders, supply chain guy who's like in charge of the actual supply chain process and reads the reports, you'll start hearing things like, oh yeah, this one field you can't trust that, and this other field over here, there are all these bad nulls in there. Oh, and this data in this column, that's actually generated by a test system that generates random events. Like 10% of those events aren't real. Maybe we have to start talking about like factory farmed data versus farm to table data or something like that.
Well, yeah, that's a good point, though. And what are some of the horror stories that you've seen? I mean, I think this is sort of the comment you made, Ben. It seems to be born from some sort of experience, and probably Michael as well. I guess what prompted that sort of revelation after you hit stop on the record of your podcast this morning?
I mean, for me was we were looking at email domains, like mail server domains for a project many years ago. And we were trying to do some sort of unsupervised learning. We're like, okay, we're going to use k-means clustering to say, hey, I want to determine the similarity between all of these, user data that I have and see if something in the domain is indicative of a latent property associated with the customer base. And the model was performing great but there was this huge skew in several groups. And we were told, like, hey, the data is good. It's sacrosanct. That's what the exact word that I got was that this has been blessed and the ETL is solid. There are no issues with it. There's all these data validation checks that are going on. But there was weird behavior in these couple of groups. I'm like, okay, I just need to analyze this data, like really dig in and see what's going on here about why this algorithm is behaving the way it is. And we found that there were two particular amusing domains that I was like, oh, these aren't real. And the reason that this is messing up the algorithm is because the people that would do this are either bots or are trolls who are intentionally trying to mess around. And they were the domains me.com and you.com. And there was one particular email address in me.com that was really suspicious. It was the word eat. And I was like, oh, okay. So people are messing around and they're putting in fake email addresses, but everybody that was doing that, I'm sure you can figure out what the you.com was. Everybody that was doing that, their behavior on the platform was so different than any normal behavior that we didn't realize that we should have been filtering out all of that because it's just spurious garbage data. But from an ETL perspective, it was good. Like the data was filled. The behavior wasn't so abnormal that it would have sent off any monitoring alarms. It was bogus data in the data set that broke the models.
Yeah, I feel like you can't even find that data until you put it into something like a model or do EDA in general, because what you'd have to know what to look for. And as you said, if the ETL is solid, I think it's a really tough detection problem without some sort of algorithm.
Yeah, and a big important thing that I learned that from that experience was I can't ever add data to a feature vector or any algorithm without going through like real EDA and that exploratory data analysis, which is build statistical tests around this thing, like actually analyze like what is the correlation between these fields, these different features. What is the nature of this data? Do I have like extreme outliers in this continuous field? Do I have one particular class, if it's a categorical type, that's just dominating everything else? And then sometimes it really is just randomly sample the data and get eyes on it, look at it and say, hang on a second, somebody's being funny, like this isn't real. And you can detect stuff. It's hard to do when you have like 100 billion rows of data in your training data set. That's really hard to sample and put eyes on. It's just impossible. But statistics can help you with doing that.
But I think this is, frankly, the new frontier of data observability as well. I think there are a lot of great data observability products that check logic, that say, okay, is this column null? Is there some inconsistency in the data structure that we don't expect? But in general, anytime you're talking about data that comes from outside your company, things like clicks, web events, third-party vendor, the data can change in statistical ways that you constantly have to watch out for. Data is entropic, like just data brings chaos inherently. And some of that chaos is actually the signal that you're interested in as a machine learning engineer or data scientist. And some of it is going to completely skew your results.
Oh, for sure. Like, definitely, for certain. That's why it's always scary to me when I see somebody build a model and then be like, all right, we're going to deploy this to production. We're all set to go. And then you ask the question as a consultant, you're going to ask this to a customer and be like, well, what's the monitoring of this model, and how are you going to check to make sure it's still doing what you expect it to do? And then you just get this deer in the headlights look back from people, and they're like, what do you mean? We're pushing to prod. I'm like, yeah, but when are you going to retrain it? And they're like, we already trained it. I'm like, no. Like, this thing is going to change like constantly. And if you're not checking for when you should trigger a retraining or just schedule a retraining, that entropy that's happening can take a model that's making your company money and flip that to making it as something that's losing your company money. It's better to just shut it off than to keep it running.
That's interesting. Yeah, I guess, when building these, the title of this, at least on social media, is building ML pipelines from scratch. I guess it's one aspect of this, but building from scratch, I suppose there's a lot of things to it, right? It's not just throwing up the good old pipeline and throwing the data in and making a model, right? It's interesting because EDA has always been one of those things where people are like, yeah, you should definitely do that in your data for sure, like inspect it and understand it and stuff. But how often do we really see that in practice, though? Or how often, I think, to the point you're both alluding to, do people just want to kind of jump straight into, let's make the model? Like that's something we should be doing right now.
That's a question of how often does it happen, or how often should it happen?
Well,
how often does it happen?
How often? Anecdotally, have you seen it happen? Yeah, and I think how often should it happen? I think maybe that's another good question. I think we all know an answer, but let's start with the first part. This is something that you see pretty frequently.
It's more common than, like, before I started working in consulting. I had an extremely myopic view of what data science and ML and algorithmic solving of problems was, because it was just like the people that I knew personally and the projects that I was working on, and people that were telling me how stupid I was being about not doing these certain things, and learning from that and be like, oh, that's why we do this. That makes sense. And then you get into consulting and you see that there's this just massive swath of diversity in how people do what they do, because the standards really haven't been written. Nobody's really said, hey, here's the agile manifesto for ML engineering or for data science. It just doesn't exist. And it arguably too complicated to write with how broad the ecosystem is. But you see people that go full cowboy mode, who are they don't even use pipelines. They just say, here's my data set, my feature table. It's got 800 columns in it. It's just a select star from that, put it into an XGBoost algorithm, and then run predict, and then predict on a random sample holdout. And they don't even tune the model. They just use the defaults and hope for the best. And they call that like, hey, here's my prototype. It's like, yeah, that's 16 lines of demo code. Shouldn't be running that for any reason other than learning the APIs. You see everything from that to a team that has 20, 30 experienced data scientists, ML engineers, DevOps, a software engineer or two in there that are writing incredibly sophisticated but smartly developed, not overly complex, but just sophisticated implementations that you're just kind of in awe of. You're like, oh, this is what happens when you have an unlimited budget and a ton of really experienced people. And a lot of times some of those people then go on to be consultants and advise, like your company. Like I'm sure those are the sort of people that you guys hire to go and advise other people on how to do this. Yeah, wide range of what I've seen.
How about you, Michael?
I would agree. It's also a wide range. One of the most illustrative examples was at Tubi, we do usually like quarterly or biannually hackathons. And it's really cool to see the different levels of approaches, both in levels of technical depth, levels of subject matter knowledge, and levels of just everything else, how hard people try on the hackathon. And there's one guy on our team that always spends like 80% of the time doing EDA and then fits a GLM to the right part of the data that has been correctly transformed and usually wins. So leveraging subject matter knowledge is super helpful. And if you don't have that, having really strong EDA skills to like pinpoint the goal and the area of the data that has the most signal, simple models can really be effective. And then they're really easy to productionize, really easy to maintain. And if you do need to iterate, they're really easy to iterate on. So starting simple, like Ben and I have talked about this a lot on the podcast, but starting simple and iterating is such a good approach for so many different reasons.
That's interesting. What are some of the simpler models people could start with?
Oh, I mean, I always recommend, and Michael, you've heard me say this a couple of times, start with an if-else loop or conditionals. Like that is, technically speaking, that is an algorithm. You're defining the decision characteristics of what this decision to make. And I've had conversations with customers before and just general people like, well, I can't use something that simple because that's not ML. Like, what do you think decision trees are?
Right.
Like, have you ever printed out a decision tree? That's an algorithm. And look at the results of it. It's making decisions based on your coefficients of where it should be grouping, bucketing based on just randomized splits. And then it's saying, all right, here's where I get the most signal, my most amount of minimization of entropy in the difference between these two split conditions. There's nothing wrong with that. And that's usually where I start, stuff like that. It's a placeholder that gives you a little bit of breathing room and time to work on a more sophisticated approach if you need to, which usually you need to. You don't want to have like an 8 lines of if-else statements and ship that to production. Although there are times where you can do that, and I have done that. But you leave that as a placeholder while you build the rest of your code, where you say, okay, what do we need to do to our features? What manipulation needs to happen to this data in order for us to be able to leverage a signal that we found through EDA, and write that code, and then write your unit test for that, and then write a little stage pipeline that does all of those transformations and gives you your feature vector. Now write a larger integration test for that process. Make sure those tests pass and make sure that they're configured to run every time you check in code to a PR. Then you're ready to go off and go modeling if you need to.
I don't know. Go on.
I was just going to say also, linear regression is, people assume that's a good starting place. So start off with if else if you're crazy like Ben, and then go up to a linear model. That linear models are usually a good starting point, but be careful. Like the assumptions in linear models, there's like 6 or something, and they can be violated in so many different ways and with differing levels of severity. And a lot of these things, like Joe, you were talking about AutoML. AutoML prevents the need to actually get deep into the data and really understand what's going on, have statistical assumptions, etc. So these simple models are not always as simple as you think. And I remember I was talking to one of my buddies about his stats course when he got his master's in data science, or whatever the official term was. And they spent legitimately 2 semesters on linear regression. because there's so much in there. There's so much depth. And then moving on to more complex things is definitely more computationally complex, but from an assumption standpoint, you often just throw assumptions out the window because you don't even know how to think about inference for a neural net, for instance. So be careful with the simple solutions too.
Yeah, that's interesting. It brings up a couple of interesting points. So first of all, I'm aware of cases, more than one actually, where people tried really sophisticated models, deep learning, all kinds of techniques thrown in, and eventually they found that the linear regression models outperformed all of their sophisticated models by a margin, and that's what they deployed into production. And then the second question, I mean, the second point you kind of raised with this about being careful is, is there a degree of monitoring accountability where often these models have a direct financial impact? They can have an impact on people's lives. I think we think about monitoring for basic things like retraining the model, but what about monitoring to make sure that you're not costing your company a bunch of money? I mean, that's part of that bigger problem, but it seems like there's almost what I would call a FinOps aspect of this. Of course, FinOps has emerged in the cloud space, like monitor your infrastructure to make sure someone didn't spin up a 1,000-node Databricks cluster. Is that just an example? It's costing you a ton of money. Should we be doing the same stuff with models running in production?
It's like ML FinOps or something.
Yeah, exactly.
Yeah.
I mean, 100%.
Yeah.
When I've interacted with customers who have been a Databricks customer for a while, and they're getting ready to ship something that's legit, like real production ML code, they've dotted all their I's, crossed all their T's. It's solid implementation. A lot of those questions are like, hey, this is expensive. Like, training takes 16 hours. This is my cluster configuration. These are my instance types. And are we doing this right? And I can count on one hand the number of times that I've spent a week reviewing all of their code and their configuration where I'm like, no, you're good. Like, this is exactly how we would do it. The other many dozens times, it's more like, yeah, you're at 5% utilization on your like executors. And the reason it's taking so long is because you're partitioning your data out and it's having to shuffle across so many different VMs. So don't do that. Or you're trying to run it on a high concurrency cluster and there's resource contention and context switching, not only on the driver, but on the executors. Don't do that. Like, set it as a job-based thing and make sure there's only one Spark context. But monitoring for that level of production deployment, there's always two things that I recommend. The financial stuff is incredibly important about how many machines are we spinning up, how long are they running, when we're doing inference, are we scaled correctly? All of those are very, very important. And if you're not looking at them, I guarantee somebody at your company is looking at them. Who you don't want to have looking at them is the CTO, who's the first person looking at it being like, what the hell? Like, why do we have this massive cloud bill right now? Been there, by the way. But the other part that I would argue is even more important is the monitoring of how your model interacts with reality, with the world. If you're doing an ML project, it should never be just for fun. If you're working for a company, it should always be, there's some reason we're building this. Like, we're increasing efficiency of this team, or we're automating something that is killing the neurons in this team's mind because it's so boring to do, or we're increasing sales, or we're reducing cost. There's something that thing should do because it's a business that's trying to make money. So if you're not measuring your model's impact to that metric and being able to say, hey, in this last quarter, we made $17.3 million. That is the lift amount that we calculated. If you're not monitoring that, the chances that when somebody gets the cloud bill and starts asking questions of like, hey, what is the ROI on this? Like, are we losing money by running this thing? And you can come back, if you are collecting all the data properly and analyzing it, that's a 5-minute email response to that CTO. Like, hey, yeah, it cost us, $25,000 to run this job this month, but by the way, we made 17.3 million, so we're in the black. CTO says, awesome, cool, thanks for the analysis. But that should be pre-canned and monitored because you want to check that trend over time.
That's a good point. And plus the salaries of all the data scientists too. So,
Yeah.
Which then equals about the 20, about $16 million or something like that out of the 17. So,
So I don't know what you're paying your data scientists.
I'm just kidding. No.
It's a tight market these days.
Yeah, it's a tight market. Yeah, that's one of them. So just kidding. Now that's a really good point, because everyone talks about. I mean, this is the thing that Matt and I, we riff on a lot. Is like, I think people want to talk about adding value, to data and stuff, but it's sometimes it's easy to quantify and sometimes it's not. But ideally, it should be, right? So, I guess in cases where it's not, like, what would you do?
I've never found it to be easy.
Right.
Like,
yeah.
For instance, for some of the projects I worked on when I was working for companies other than Databricks, we were doing stuff like a big project I worked on at my last company was a recommendation engine for an e-commerce site. And it had a bunch of different aspects to it that it wasn't displayed in just one location. It's like displayed in a bunch of different things. And we used the results from the model for different use cases as well. So we had to run tons of A/B tests, but keep these A/B tests running perpetually and do automatic refresh adds to our cohorts. That's a whole bunch of code you have to write to figure that out. Like, hey, each day, how many new users did we get in? What percentage get, the control? What percentage get the test? What is the test control ratio that needs to be happening? But we had to split people up, not just on a random sample, but we had to reshuffle based on RFM groups. And that's a whole nother algorithm that needs to be developed and ETL that needs to be written just to be able to split people for the A/B test. And then we had to run statistical jobs that ran each day, looking at our sales, looking at our orders, looking at our return rate, looking at all these aspects of business that we didn't build in a vacuum. We had to talk to finance team, to marketing, product specialists. We had to get all these people together to build all of that infrastructure just so we could answer that one question: how much money is this making us?
Interesting.
It's a lot of work. And then there's other times where people are like, yeah, I'm creating this algorithm that does this thing or this ML-based service, and it's not intuitive about how to measure it. But any problem, if you're checking code in to a service, there's always a way to measure whether it's effective or not. It could be A/B tests like, hey, you can see this service, you can't see this service, and how long do people stay engaged with your platform? It could be actually sending out surveys and talking to trusted users of your platform and saying, do you like what we're doing here? And then sending out to enough people, you'll get a percentage response back, and you just track that rate over time. That's what we do at Databricks for new features that we release. We have a private preview stage of any new feature where we selectively ask customers that can give us candid, which translation, extremely honest feedback about this new feature. Is it good news? Not always. Sometimes it's really bad news, but it helps us iterate and get towards a better feature set that people can be happy about. And then you do another preview of a gated public preview where you open it up with the caveat, hey, this could be broken. We'll fix it if it's broken, but we're not providing official support because we're still working on it. And then eventually you leave it open to a general release, but you still ask people on like, hey, for this feature, what would make it better? And we use that as a measurement of what is the value that this thing brought. And then we calculate utilization based on how many times somebody uses that API. How much money does that directly generate for us? How much more time are they spent on a cluster using this? So it's all data driven, but sometimes you have to get really creative about how do I collect this data?
It's really interesting. Oh, go on, Michael.
Yeah, another point that I think, so there are two components, right? The value added through the model and the time it's spent, time, money, et cetera, spent developing the model, let's say. Time, money, et cetera, very easy to quantify. Look at salaries, divided by number of hours, good to go. Add server costs in there, and you can actually come up with a number, not easily, but it's calculable. The hard part is knowing what the production environment would look like without the model, and then comparing that control versus the treatment, which is having the model. And Ben was saying you can leverage A/B tests and things like that, and it's usually a good idea to run A/B tests before graduating anything. But it's really hard, let's say, if the model might deteriorate experience over time or increase experience over time. You can't run an A/B test forever. So you have to say, all right, if it's good for 2 weeks, it'll probably be good forever. That's often not a valid assumption. So one solution, if you have the engineering bandwidth, is to have global holdout groups, which are groups of users that don't receive any of the new features. And let's say it resets every quarter. You can then assess the impact of, let's say, the ML team and all ML algorithms relative to that holdout group. It's still sort of hard to isolate specific algorithms, but that's one way to do it that's super statistically robust. But then you need a prod version. Well, you need to support at least 2 prod versions that are bug-free and have a good user experience. So it's really tough to build, but it is a very statistically robust way to go about it.
It's an interesting problem because even in like academic statistics, I feel like this is a tough problem. And I've also, on top of that, seen it become very political within organizations. So I've seen situations where teams rerun the same A/B test multiple times. Sometimes they get a positive result, sometimes they get a negative result. The reality is that none of them are statistically significant. But once they see a result with some lift, not statistically significant, they're like, oh, here it is. Like, we won. See, look at all this money we're making.
Even if it was probably premature too, right? Even if the test wasn't supposed to end, it's like, well, here we go.
Yep, exactly. Calling
Test
it
is over now. Yep. So, yeah, I think it was Shay Sharma from EPO actually talked to the Utah Data Engineering Meetup a couple months ago, last month, and talked about A/B testing in that regard. He had this interesting graph where it was p-values over time for an experiment, and they swung all over the place, all over the place. It was basically a random guess. It was a random walk almost. So if you've seen those, it was like, I don't know, what day of the week is it, and where's the p-value? It's significant. It's not significant. It's actually very random, which shouldn't be the case, maybe. But he said the danger in A/B testing is obviously picking a value where that is very convenient for you. But this happens not irregularly. So,
and introduce the complexity of the vast majority of tests that I've seen where people are claiming a p-value, they're not even using the right test. I see a lot of people do lift tests where they're using like a z-score when they're talking about revenue or sales. It's like, hey, that's not normally distributed, so that's not the right statistical test to use. You should be using like Fisher's exact test or rank sum order test. And then people are like, what is this? I'm like, no, it's in stats models. I'll show you. And this is what the API looks like. And then they run it and they're like, oh, it's not, it's got a p-value of like 0.4. I'm like, yeah, run it for longer, calculate your power factor for how long you need to run this test. And what you want to determine is a significant difference, because everybody uses like it, for some reason, an alpha of 0.05 for these things because it's the default. Right. It's just a placeholder. Like, it's meant to be changed. If you were in the medical device industry, you should probably be using an alpha of like 0.01 because you really want to make sure that you didn't, introduce something that isn't effective or could be bad for people. But if you're in the e-commerce world, you don't have to be 95% sure. You can be 80% sure. It'll be good. It'll be fine. You don't have to run your test for so long to get that difference. But if you're running that test and you're doing the calculation, like, all right, I have 1 million data points between test and control, and you're like, I don't see any difference. It's because there is none. Like, stop the test, go back, change your implementation, and try to solve it. And then set a limit on how many times you're going to iterate. Not every problem is solvable with ML, which is
That's
unpopular
heresy,
opinion.
Ben. Jeez. Well, that concludes the show for today.
That's right. Data is worthless. We're all going to go find different careers.
No, it's fine. Kind of switching gears a bit. We're talking about stacks, pipelines, and stuff. Like, what is there a kind of a standard modern ML stack or an ML pipeline to ML stack that people should be thinking about right now and implementing? Or besides ML Flow.
Wow, what a loaded question. ML Flow isn't a full stack quite yet. Shameless plug, we are a team member who's a principal engineer at Databricks in ML engineering, Jean-Marie Meng, has just came up with a new proposal, sort of his manifesto for ML Flow 2.0 called MLX. And that is templatized pipelines that simplify the ML ops end to end, from conceptualization to creating the code that you're going to use for that algorithm all the way through deployment. But we're just starting work on the prototypes for that. There isn't, as far as I think any two data scientists could agree, a standard in industry yet. I mean, we're 30 years behind the software engineering industry about setting, like, hey, how do I do deployments? Most people are like, well, you run your CI on something like Jenkins. Like, if you have a large scale infrastructure, you should be running your test on some test management, platform like that. For data science, there's probably 20 different tools that you could use, and you would have to glue all of that stuff together. I don't know about for you, Michael, like what your experience is for the hodgepodge of solutions out there.
Yeah, I think it's super company specific. So larger companies tend to have a full infrastructure that you can plug and play. Startups, you have to use everything that's open source, and if it's not open source, hack it together. And then there's obviously a huge middle ground. So I would agree that there's no one solution, but I think it's starting to standardize a bit, and hopefully ML Flow will be a really good solution. Well, I know it will be, but
it'll be the best one out there.
It'll be by far.
Yeah, I mean, as talking to Dimitrios from the MLOps community about this a few months ago, we're kind of riffing on, well, is there because we're talking, actually, it's at the Teton office with Mike Del Blasso, actually, we were talking about sort of on the podcast, is there a modern data stack equivalent for ML, right? And it's kind of like, that's a good question. I don't think that there is, actually. It doesn't seem like there would be. There's, for one, there's a variety more use cases too, like image classification or video or whatever you want to do, anything you want to do, frankly. So it'd be hard to reconcile into one stack, I would think. I know people are working on this. Like, I think Dan Jeffries is working on it with the AI Infrastructure Alliance and probably a few other efforts to consolidate a common architecture. But it seems very, still super early days, you say. It's, I mean, we can barely get deployments right. That's not really like a word in most people's vocabulary at this point. So it's just like, let's start with the baby steps. Alec Dutcher actually has a question here. Kind of related, actually. It's kind of more I wanted to steer the question and not towards like a loaded question, which I accidentally like blurted out. But is there a minimum stack necessary?
Depends on what you're trying to do. So this is a good lead in from what you were just saying, Joe, which is like a pipeline exists for something like TensorFlow plus Kubernetes. You have TFX that can sit there, and you can define a DAG or pipeline of operations that you're going to do from data acquisition all the way through to a serving layer. That's just for deep learning. It's just TensorFlow. What do you do if you need to, run a binary classifier that you have this really small budget? You don't need to run TensorFlow on Kubernetes for something like this, where maybe it's a batch job that's running once a day on 1,000 rows of data. You could run that on your laptop. You shouldn't, but you don't need all that infrastructure. But a minimum stack, I always ask, what are you trying to solve? So is this something that is, can it be solved in SQL? Do that. Write a script that'll kick that off. Schedule it with cron. Done. Move on to the next cool problem. If you need to use something that's like classic statistics based or temporal based, like you're doing forecasting, then you need to think about how you're acquiring all of your multi-series data. Like where's the data stored? That's going to be part of your stack and the infrastructure to get that data out of that. And then execution, you need some place to run that algorithm. You're probably using something like Prophet or PMD Arima or stats models, or one of the wrappers around that, those algorithms. And the question is concurrency. Like, how do you you just have one series to forecast? Well, how many iterations do you have to do? How big of an infrastructure do you need, and what tooling to support that? But stuff like forecasting is miles away different from like reinforcement learning. If you're going down that path, you need a completely different tech stack. You need different hardware and different frameworks that are going to be involved there. So it's so use case specific. That's why it's really challenging to create a unified generic framework to do all this, because the steps, the user journey from project ideation to monitoring in production is so different depending on what project you're working on.
The outcomes are all different too.
Yep.
So like the forecasting model probably isn't what you're going to use for your self-driving car model. I would hope not. That'd be weird. It'd be a really smart car, actually, if it could do all that stuff. But or smart, yeah. What do you think, Michael?
I was going to take sort of a different approach and like completely agree, but it's really useful to break down the process into its key sections. So the first is getting data to the model. The second is the model. And then the third is outputting the data for use, or the prediction for use. The simplest, like the minimum tech stack necessary, is a CSV into a linear regression, into an if-else statement, excuse me, which will be then consumed by you with your eyes as you do some action. So that's the minimum stack necessary. And then for each of those, as it doesn't meet your criteria for success, you then can increase in technical ability or technical level. So I think it's really helpful to think about it in those three steps. And obviously data source is important, UI at the end of prediction is important, and you can start adding on to those pieces. Those are the three fundamental areas that can be iterated upon.
That's a really good thought.
Yeah.
Any thoughts, Matt?
I'm going to ask another question. So Joe and I have seen just this mass proliferation of companies in kind of the modern data stack space and observability, like data observability companies. From your perspective, are you seeing the same crazy proliferation of startups more on the ML and data science side? Let's say startups and open source projects.
Yes.
Okay.
From my perspective, some of them are awesome. I'm not going to name drop because I'm going to insult people for leaving them out, but there's some projects out there that have definitely piqued the interest of people that are on the team that I'm on now. We're like, that's really cool. Like, we should think about an integration with that. Or, hey, let's reach out to them and have a chat and see if we can make jointly make an official plugin with what they're doing, because this is awesome. And then the other 95% of them, it's like, yeah, cool. Good luck. A successful open source package is not just functionality. It's also reaching an audience and building faith with that audience to say, hey, guess what? Yeah, this is open source, but we're actually devoting professional engineers' time to maintain this and to make sure that this is a quality project, not just for the next 6 months, but we're in this for the long haul. It's part of our platform. We're doing this for realsies, and we're going to be maintaining this for 10 plus years. Once you can get that street cred out there, people start saying, hey, maybe this is a good idea. And they let me contribute to it too. This is a permissible license. Like, that's how you have to build that ecosystem. So it's challenging.
It really is. Yeah. And the problem is that there's so much money sloshing around, so many new startups. And the question in everyone's mind is, okay, if I adopt this, will the money dry up at some point? And will this company continue as a viable concern? And will this company backing open source continue? Or if they die out, will someone else pick up the project and keep going with it? What's your perspective on this, Michael? You were talking about the minimum stack, or now we're talking about sort of this like dream toolkit that we all have access to, but we're scared to use because any of these products might die in a year or two.
Yeah, I mean, I think that having, like as Ben pointed out, having a really strong community around an open source library is the key, because stuff changes and it needs to stay current. And so if we have that, I think we're pretty good to go. And if not, I would trust a proprietary service more, because they are paid to maintain it. But yeah, that's just my 2 cents.
Open source is an interesting one too. I think I saw some numbers on requests. I think it was a library, or maybe it was one of those Python libraries. I think total contributions for the year, donations was like $13,000. So I think it was like one of the most widely used Python libraries in the world.
Oh, wow.
So, yeah.
Okay.
I was like, okay, so let me see if this was a startup, say that we'll call it, I can't remember if it's a request or not, but say for argument's sake, it is. Okay, so widely used, probably more than a lot of popularly funded open source projects, arguably more important because it's used everywhere, yet doesn't get, as much money, nearly as much money, right, in funding. So I find that it's interesting. It kind of reminds me of something I was reading this morning, where it seems like the critical jobs in society are the ones that pay the least. So like teaching and collecting garbage and stuff like that. It was this book called Bullshit Jobs. So thanks to Todd Hansman actually for the recommendation on that. He also has a very insightful comment, like he always does. Begin with the legal pad, preferably lined. Back to the minimum net stack question. But I think it's interesting just because there's the things I think that provide a lot of utility are the ones that a lot of people are freely contributing to and probably don't make a ton of money, which I think is sort of an irony in some ways, but because it's how the market works. So,
I mean, if you ever look at those packages, something that I don't know, it's a weird habit that I have. Whenever I start using an open source package for something that isn't already part of the package that I'm messing with, I always want to know like who created it, what company they work for, and who contributes to it. And you can just sort by number of lines committed in the last 6 months or something on a repo. And I can tell you from our major open source stuff that Databricks does, the vast majority of lines of code committed are Databricks employees. But for some projects like MLflow, we have people that contribute some pretty serious features from outside our organization. Amazing implementations. You look at their code and you're like, hang on, like where is this person from? You're like, oh, Google. And then you look the next person down and you're like, oh, Microsoft. So they already get money because they're highly paid software developers at some massive company. If you look at most of the successful open source packages that are out there, they're just like that. It's just somebody who's using the library who works for some massive company. And we do it too at Databricks. Like, hey, we need to integrate with this library. It doesn't have this functionality. We'd rather not maintain a fork of that. We'd rather give this back to the community. So we just bubble it up to the maintainers and say, is it cool if we add this feature? They're usually like, yeah, please do. But they're just other engineers at another company. There are some startups that are out there. They're like, that's their only thing that they have going on. That's risky to take that on as a user. I mean, definitely explore that stuff. And I recommend that if you believe in what somebody's doing like that, I'm not saying give them money. Give them money if you can, I guess. But what's more valuable for those projects is give them visibility. Talk about it. Say, like, hey, I built a demo using this new thing. Here's what it looks like on my data, or like, this is how valuable this is. That's more beneficial to those projects that you really believe in.
Mm-hmm.
Yeah, that's an interesting one because there's a lot of whining, and I think it's understandable about Amazon's use of open source code. So, like, you can just go deploy a MySQL instance, or you can just go deploy a Postgres instance. That's fair. Amazon probably should be making more contributions. But how big a contribution is it to those projects that anyone can go and just start up Postgres or start up MySQL in terms of buy-in for that ecosystem? And so on the one hand, yeah, Amazon is kind of taking money out of your pocket if you sponsor a project. On the other hand, if they're offering it, then it's probably going to be around for a while. Like, it's probably not going away anytime soon.
Oh yeah, definitely. Like, we've had that philosophical debate at Databricks about EMR, and a lot of people are like, well, when you go into an account, like an Amazon account, that like they've been on AWS for years, and then now they're talking to us, you never hear from Amazon like, oh, you shouldn't use Databricks, you should just use EMR. Amazon doesn't care. Like, I can confirm, I've never met anybody from AWS that's like, oh, Databricks sucks. They're usually like, no, it's awesome. Like, please go with them. It's better than what we offer. And we'll even give you credits to convert over to this. They're super welcoming because we're very tight partners with them.
Mm-hmm.
I can't speak to other projects though. I think they like us because we bring them so much money in the form of cloud infrastructure costs.
Well, yeah, I mean, so for the audience, I mean, clouds make their money in a couple ways. It's compute. It's a big driver. I think last time I checked, it was 75% of the revenue came from some form of compute generation. I think there's a Corey Quinn thing or something I just made up. But then it's storage and other stuff. But yeah, compute's like the main driver behind that, plain and simple. So anything drives compute, they're happy. They win either way. So great business to be in. So
and yeah, all three clouds are like that as well. You know,
mm-hmm.
they're just, I think they want even more partners to come on and say, hey, here's something that works for users on this cloud platform. They'll go to bat for a service that's doing that. Now, if there isn't a company that's offering that service that's native, that's big enough that can actually communicate with the cloud provider at scale, if you're a small startup releasing this cool new package, if you don't have the business connections to get a seat at the table with Amazon or Microsoft or Google, but the package is popular, yeah, they're going to offer it.
Mm-hmm.
I mean, why wouldn't they? They can. I mean, I would too if I was them, because it's right for their customers.
Right. I guess kind of on the notion of ML engineering too. I mean, the clouds have their stacks. You know, AWS has SageMaker, GCP has Vertex, Azure has, I'm not as familiar with Azure, but they have whatever they have.
Azure ML.
Azure ML. Yeah. Okay. That's what it's called. So, I mean, where do you see sort of, and these are all kind of end-to-end solutions, really. I mean, if we talked about maybe a stack, I mean, they certainly have a version of a stack, right? So you could get data in, get predictions out, however you want to do it. But do you feel like we're in early days of the maturity of kind of ML engineering, or do you think that that's kind of epitomizes where things should be? I mean, what are your thoughts on the evolution of ML engineering stacks, both in the cloud and I think from a vendor perspective? Complicated question, but
I mean, any solution that exists on a cloud is not end to end. You have to glue all those services together, and that's a lot of work for your DevOps team, a monumental amount of work. SageMaker, yeah, you can run a model, you can monitor models. They have lots of features around that. I've used it before. I think it's a great product, but you have to get data into there from somewhere, which is usually S3. So where do you run a query execution to go in between those? Well, maybe you need to trigger the job. Well, how do you do that? Is it triggered based on data coming in? Now you're talking about, okay, I need to create a query statement. So I need an SNS event to go to SQS. I have to set all that up. Then I have a Lambda that's in there that's going to be triggering based on some event. And then that's going to trigger, me running, some Fargate job that's managing my EC2 instances and my Elastic Container Service. Well, do I have to, run all this on Kubernetes because that's my stack? Well, now I have to set up EKS and I have to get that data piped to that from EKS. Where do I go then? Do I write it back out to S3 or do I create a REST API? Well, that's another service. Can you build all this stuff end to end? Heck yeah. But is it something that a team of 3 or 4 data scientists can sit down and in, as we were talking earlier, Michael, the 7-week time limit, can we have people that have less than 10 years experience sit down and do all that, like a team of 3 people? No. Like, that's going to take months to build all that, test all of that, make sure that you have a dev environment, a pre-prod, and a prod environment, and all the monitoring set up. And you got to have a big wallet because that's not going to be cheap.
I mean, the time alone, right? The employee time alone to spin all that up is going to be expensive. Yeah, SageMaker is great, but like we've tried to deploy it with clients who are mostly just analysts. They can get their notebooks running, move them off their laptops, but then we hit a wall because even to schedule a SageMaker notebook is a huge pain. Like, okay, we got to write some custom Lambda code, and then we have to trigger the Lambdas on a schedule, and then we have to monitor that they actually run. And yeah, not easy.
Yeah, and as a consultant, you're against the wall with this.
Right.
It's not right for production to be like, hey, when you need to retrain this, turn on your laptop, change this string at the bottom about where you want to write this, and then just hit run all. We know that's not right. But if your client needs production deployment sophistication and they're not experienced enough to grok everything that you need to build, that's a problem.
Mm-hmm.
It's a problem for the client, and that's also a problem for the consultant who's building that for them, because that's your reputation. If the client's like, they built me something I can't maintain,
right?
And it's like, okay, now we need to do training consulting where we have to teach you about these systems, and it's just more money. Basically, what I'm saying is it shouldn't have to be this complex. And I think in the future, that's what we're trying to do at Databricks for the ML journey, is simplify all of this stuff. It's not that hard to write ETL anymore. You have tools now that are simplifying this to the point where you don't need 15 years experience and a PhD in computer science to be able to write an ETL pipeline for an enterprise account. Pretty much anybody can learn how to do it, as long as they understand software. The same should be true for not all ML. ML research is a different topic, but that's why it's called research. But most use cases that people are doing, you're doing stuff like churn prediction, fraud detection, revenue demand forecasting. You're doing like inventory demand. How fast are we going to sell out of this product? When do we need to reorder this product? What is the most efficient route to get, to send our packages on a truck to go across town? How long should I tell my customer that it's going to take for their pizza to be cooked when they order it? These are effectively cookie cutter ML, and it's 80% of deployed ML is this sort of thing.
Right.
It should be simplified.
Totally agree. Yeah, I mean, what's up?
I was just going to say, what's your perspective on this, Michael? Do you have to do DevOps, or do you guys have a DevOps team that takes care of some of these details for pipelines?
I'm actually not on the ML engineering team. We have an ML engineering team that does a lot of the DevOps. But when we tend to take ideas and build them into proof of concept prototypes and then hand it off to CS people with more software engineering experience to actually productionize. But sometimes that's not the case, and we actually do all of the DevOps. So as a sort of mid-sized company, we're not where we want to be, and tooling like Databricks or just more end-to-end pipeline work, tools that do that for us would be really, really appreciated, at least by me.
Got a question here from Chris Tab, and I think I understand what he's asking, but I want to see. So he asks, do you see taking the training model to where the data is versus right now you have to take, he says, SageMaker requires you to take the data to it. Do you, I guess maybe if Chris is asking that question, are you suggesting taking the model to the data as in a reverse way, if I'm reading that right?
So, I mean, that's what Databricks does. It's all in one platform.
Yeah.
So your data exists on object store, whether it's encoded as Delta or as Parquet or JSON, whatever. But when you execute training, yeah, you're loading that into memory on a cluster or on a single VM, running it, and then you're exporting the artifact to MLflow. Everything is there within, if you're on AWS, it's on S3 object store. So we are taking the modeling to the data. I'm not sure if he's asking about stuff like approaches like what Snowflake is trying to do, or
I'm not sure. Chris, if you could clarify your question a bit more, that'd be good. Actually, I'm running up on time too, so kind of jetting a bit. Cool. I guess kind of closing out. I guess where do you see ML engineering going over maybe let's call it the next 2 years?
More simplification from my perspective. More of a homogeny of tooling where things it just shouldn't be as hard as it is right now. And companies are putting a lot of money, time, effort, and talent into solving this problem, because the amount of things that I know that everybody says the tagline of like, oh, if you're not on, going down the AI driven path, you're going to be a dinosaur in 10 years. People were saying that 10 years ago. It's not true.
Yeah.
But it does provide an awful lot of value to a customer to a company that does it right. The things that it can improve in your processes so that you can understand more about your customers or about your business and make you more money so you can hire more people to do more cool things. There's a lot of things that this level of automation supports, and making it more approachable is where I see ML engineering going.
That's really cool. How about you, Michael?
I completely agree. I think we can use a very helpful analogy of software, where ML is where software was, let's say, 20 years ago, and we're building out tools and infrastructure that facilitate the software development process. In this case, it's the ML development process. So roles will change to be more building tools and leveraging those tools to quickly build models. So I think right now you need a much more of a full stack skill set, and hopefully that'll change to be either a lot more subject matter plus stats plus the actual ML algorithm, and then on the other side, people building the actual tools. So I think roles will change in that way, just like they did with software.
100% agree.
That's awesome. Well, for people who want to learn more about you two, how would they do that? We'll start with Michael, since he spoke last.
Hit me up on LinkedIn. I also have a website on there. All the links are there. And then I also have a blog on Medium. And so if you want to hear academic research being dumbed down, hopefully not too dumbed down, but explained a bit, check that out. And then also Adventures in Machine Learning podcast with Ben.
Can confirm his blog post isn't dumbed down. It is refined. I find it fascinating. Definitely give it a read. You will not be disappointed.
That's cool.
For me, LinkedIn, primary contact if you really want to reach out and ask me anything or just chat. You can also ask questions about MLflow on the MLflow GitHub repo. You'll probably see me answering questions there. And we're always looking for more contributors, committers. If you have an idea, file an issue, please. We'd love to chat and hopefully have more people contribute. You can also see my book on it called Machine Learning Engineering in Action, published by Manning. Paper copy released in May. It's available as an ebook or pre-order for the paper copy on Manning's website. Yeah. And of course, the podcast with Michael.
What's the podcast called again?
Adventures in Machine Learning.
Adventures in Machine Learning. And yeah, we did an episode. Go check it out. It's a lot of fun. It was different. So, but in a good way, not in like a hair shirt way. So,
I want a signed copy of the book. I guess I'll have to come track you down after I get my copy from Amazon and find you so you can sign it.
Yeah. Let me know next time you're in North Carolina.
Perfect.
Yeah,
Sorry,
awesome.
are you like research? Where are you in North Carolina?
Just outside Raleigh.
Oh yeah. So I have friends near there.
Yeah,
Okay.
there's a chance he might actually take you up on that then.
Yeah,
So cool. Well, thanks to the audience for the questions. Next Friday we have Todd Hansman and Mariah Peterson, some peeps from Utah. We're just going to be talking about data, machine learning, whatever. So it's going to be a lot of fun. And the Monday morning data chat, we have Greg Kakio, two-time LinkedIn top voice of data, technology, AI. So that's going to be a lot of fun. And yeah, we'll see you all next week and have a great weekend. Take care.